this video, we are going to discuss the solution for consecutive number sum. So it is a hard type question, but it is very easy to solve once you know its solution. So let's see how we can solve this hard type question, which is actually not that hard at all. So let's see how we can do this. So coming to the question, in this question we have been given an integer n. Let's suppose n equal to 15, and what we need to do is we need to find the number of ways in which we can write n as the sum of consecutive positive integer. So what do you mean by sum of consecutive positive integer? We just need to tell how many ways are possible by which for which the sum of consecutive positive integer is equal to n. So for n equal to 15, we have 1 plus 2 plus 3 plus 4 plus 5. This is a consecutive positive integer sequence, and if we add them, we will get 15. Another sequence can be 4 plus 5 plus 6 going to give me 15. One more sequence could be 7 plus 8, which is again going to give me 15. My fourth sequence could be 15 itself, because sum of consecutive positive integers. Okay, now you can see we don't need to find the entire sequence. We don't need to find 1 2 3 4 5 4 5 6 7 plus 8 or 15. We just need to count the number of ways. So how many ways are there? 4 ways are there. So this 4 is going to be my answer. Okay, now I can say that I can create some sequence for consecutive positive integers by choosing some k elements, right? For example, I have to choose k elements. Okay, for I can choose one sequence in one consecutive positive integer sequence, two positive consecutive number sequence, three number sequence, four number sequence, five number sequence, dot dot dot, up to some upper limit of k, right? Because you can say that I can find some k elements number of sequence. So for example, for k equal to 1, meaning a consecutive positive integer sequence in which only one element is present. Is it possible to have the sum as 15? Yes, it is true, because we have 15 here. For choosing only two element sequence, is it possible to create 15? Yes. So if we choose three element sequence, can we create 15 by their sum? Yes, we can. Can we do for four integer sequence? No, we can't. Can we do it for five integer sequence? Yes, we can. So like this, we can just check if that many number of if k element is existing or not. Oh, sorry, if we choose that many elements, does any sequence exist for creating their sum as 15? I just need to check that. How I'm going to check that, I will do this work later. Okay, but first I need to do is I need to find the some upper limit for k, because I don't know till how many element sequence I need to check. Okay, how I'm going to check, I will discuss this later. But first I need to check for how many letters, for number of uh, how many number of consecutive positive integer sequence I need to check. How many element in that sequence should be present. So I need to first find upper limit for the k. So for that, let's suppose that I have some sequence that is starting with x. Okay, x is start of the start of sequence of consecutive positive integer. Okay, x is start of sequence of consecutive positive integer, for which when we do there's some x plus 1, x plus 2, dot dot dot, x plus k minus 1, because they are k elements. Okay, this will give me their sum as n. So this is something what I need to find. Remember, x is my start sequence. Start sequence of what? For consecutive positive integer whose sum are going to give me n. So this is first equation. Okay, let's try to simplify it. So I will have x, again x, again x, and dot dot dot, again x. And how many times this x is going to be itself? K times, because I have discussed that we have k elements here, so this will be k times. All right, plus 1 plus 2 plus 3 plus 4 dot dot dot, k minus 1. All right, now as I discussed that they are k elements, so this is going to be k times x, right? Now look at this carefully. Isn't it the sum of n natural numbers? Instead of n we have k just. So we know the sum of n natural number is going to be n into n minus 1 by 2. So we are going to write it here just in terms of k into k minus 1 by 2. That's it. And equal to, now we have one equation. Now for solving this equation, either I should know the value of x, or I need to know the value of k, or I should have one more equation involving x and k. Now this is an equation. Either I need to find x and k, x or k, or I should have one more equation. All right. And why I'm not saying that I need one more equation or one more variable for n? Because n is already given in a question, given integer n. And when we are trying to solve this equation, we are already aware what our n is. All right. So n is already given. So either we know x or we need to know k. Now, look carefully at this statement. What this says is sum of consecutive positive integers. So my x should be a positive integer always, because x is starting off sequence of consecutive positive integer. X is always going to be positive. X will be always positive. This is I know. Okay, now let's try to simplify this in terms of x. So if we will do this, then we will get n minus k minus 1 divided by 2 and whole divided by k. Now this is the same equation here, and we know that x is always going to be greater than 0. Now we are just going to replace x here. So I can definitely say if x is equal to this and x is always greater than 0, then n minus k into k minus 1 divided by 2 divided by k is also going to be greater than 0, right? And if this is true, then I can definitely say the numerator of this equation is also going to be positive. Alright, if this is true, then this is also true. Now we have an equation in which we have only k and we have something we already know and is known. Now with this we can at least create a condition for k into k minus 1 should be less than 2n. This is the equation for telling me the upper limit of k. This is going to tell me upper limit of k because I already know k is going to start at 1 and I don't know where it is going to end. But now I know this is the upper limit for k. Now I'm going to check only for these values. I will run a loop from 1 and I will use this equation for the condition of my loop. Okay, now we know how we can find the upper limit for k. Now, as I told you earlier, I still need to find a condition check for these. I don't know, I just said that for k equal to 1, meaning if there is only one element present, it is possible to have a sequence which whose sum is equal to 15 or whose sum is equal to n. I have k and I have to tell if it is possible to have their sum of consecutive positive integer as n or not. Okay, now for this equation is going to come handy. Okay, because now we know x and now we know k because we have put a condition on that. We already know n. Okay, so let's write this equation down here. X equals to n minus k into k minus 1 divided by 2 divided whole by k. In this equation I can find if the number of elements that I have chosen is valid for creating a sequence whose sum is equal to n or not. Now look at this carefully, very carefully. Do I need to find the start sequence? Am I finding the number of ways or the way to create the sum of the sequence? I'm just trying to find the number of way. Look here carefully at the question. The question says have to find number of ways. Let me highlight it. Number of ways you can write n as the sum of consecutive positive integer. Don't have to find this entire sequence. Just need to find if it is possible or not. Okay, so for that we just need to check this condition. Now what is this condition? I said that the sequence is going to be consecutive positive integer. So this x, which is just what? Start sequence, start of the sequence. If this is the start of sequence of something called consecutive positive integer, then x is always going to be positive, which means that x is always going to be greater than 0 and x is also integer. Isn't it true? Consecutive positive integer. So first thing positive, second thing integer. And how can I check if this thing is integer or not? This x for my k is integer or not? Simply I can check if n minus k into k minus 1 is completely divisible by k. And why is that? If this is completely divisible by k, then only x is going to be an integer. X is valid only for this condition, because if there is any remainder, then it will mean that x is the not integer. X is not integer. So for this, I'm going to check only this condition. This is for my checking of upper limit, and this is going to be my check for what? Check for checking check for if that that k is that number of elements is going to create a sequence for which I can create a sum equal to n or not. Okay, now this is going to be very simple to code. We just are going to implement these two equations and we are going to find a solution. So let's implement it now. All right, then let's implement it now. So first thing what we need was our answer that we are going to return. Okay, now for int I, not I, we were trying to find the k. Okay, we know k is starting from 1 and it is going to follow this condition: k into k minus 1 is less than 2 times of n. Okay, so k into k minus 1 is less than 2 times of n. Okay, k plus plus. Now we just need to check for our numerator if our numerator of x, this x is divisible by k or not. If it is divisible by k, then x I got is the valid x, and the sequence, the consecutive positive number sequence exists for which the sum is equal to n. So let's write that n minus k into k minus 1 divided by 2. Okay, if my numerator is divisible by k, then it means one way to create a solution, one way by which we can calculate the sum of consecutive numbers forming n is found. So that's it. We added one to it, one to our answer, and now we are just going to return the answer. Okay, answer. Let's run it. So we have successful submission for our sample test case. Let's submit for all test cases. So we got successful submission for all 5 test cases. Okay, now if you look closely, we were told to find the number of ways, but we had derived this equation which was telling us the start of sequence also. So if we actually wanted to find this entire sequence of consecutive positive integers, this entire sequence, we could easily find that. But as we were told to only find the number of ways for which we can write n as the sum of consecutive positive integers, so we didn't use this equation x equal to n minus k into k minus 1 by divided by 2 whole divided by k. But if we were told to do so, we could easily done that because we already have the equation. Now I hope that you have understood the solution for this problem very well, and even if you don't, I will suggest you to go through this video once again and see how I reach these equations, because the solution is not important than the approach. Once you will learn the approach by which I have reached these equations and how I have formed these equations, then you will be easily able to do it for some new question. So with that, that's the end of the video, and I hope to see you in the next video with a new question. Okay, so goodbye for then.